Hello dear students, today I am going to explain kinematics only horizontal motion. Kinematics 1D horizontal motion. This is a part 2 video. Students, already part 1 video completed. Now I want to go explain the part 2 video. Kinematics 1D. Kinematics one dimensional motion, horizontal motion. So part 2. So already 1D means when a body is moving in straight line motion is called one dimensional. Horizontal means when a body is moving in a straight line. So today I am explaining some few points of distance and displacement. First of all, I am going to explain distance. Actual path of total length between initial point to final point. Actual path of total length between initial point to final point is called distance. See, once again I will explain the definition of distance. Actual path of total length. Actual path of total length between initial point to final point is called the distance. See, for example, here this is the point A, is the final point. This is the point B. So actual path means this is the actual path. Actual path of length between initial point to final point is called distance. So one more example I will do. See. This is the river. The water is flowing in the river. So just imagine only. This is your house. This is your school. So one river there, your school here. This is your house. This is your school. This is the initial point of view. This is of initial point of view. This is the final point. So distance means actual path of total length between initial point to final point. So actual path between initial point to final point. This is the initial point. This is the final point. Actual length. How to you are daily coming to school like this? This is some. Here some bridge there. You are daily coming to school like this. This is. We are covering the total path. You are covering the total path. The actual path of total length. Initial between initial point to final point. Daily you are coming to school like this. So we are covering total point. So that is the distance. So distance is the scalar quantity. Distance is a scalar quantity. So distance is denoted by the letter of S. Distance is denoted by the letter of S. Next, distance is a scalar quantity. Distance is a scalar quantity. Already previous class kinematics part 1 video I will explain what is the scalar quantity and what is the vector quantity. So distance is a denoted by s. It is a scalar quantity and SI unit. SI unit is equal to meters. SI unit of distance is the meters and series centimeter. Series is the centimeters. So see here 1 kilometer is equal to 1000 meters. 1 meter is equal to 100 centimeter. 1 centimeter is equal to 10 millimeters. These points, few points about distance. The distance is denoted by the letter of I, the letter of S. Sorry, distance is represented by the letter of S, and it is a scalar quantity. Distance is a scalar quantity. The SI unit of distance is the meters. The series unit of distance is the centimeters. So 1 kilometer is equal to 1000 meters. 1 kilometer is equal to 1000 meters. 1 meter is equal to 100 centimeters. 1 centimeter is equal to 10 millimeters. Next, I want explain about displacement. Next, I want to explain the displacement. Displacement. The definition of displacement is a shortest distance between initial point to final point. Shortest distance between initial point to final point. Shortest distance between initial point to final point. See here, shortest distance between initial point to final point is called the displacement. I will take same example. I will take the same example of distance. The water is flowing this direction. This is your house. This is your, I think, your school. This is your house. This is your school. This is the initial point of view. This is the final point of view. The initial point, this is the final point. So already previous definition, distance means the actual path of total length covered by a body, means actual path of total length between initial point to final point is called distance. But displacement means here shortest distance between initial point to final point, like this shortcut. So you are using like here some boat, you are using like some small boat, you are coming directly. So that is the displacement. Displacement means shortest distance between initial point to final point. So you are choosing the shortcut way. So actually this is total length will be covered, that is the distance. But displacement means you are choosing the shortcut. Shortcut means what is the shortcut here? When we are using small boat, we are coming directly school. That is the displacement. So displacement is denoted by S bar. Displacement is denoted by S bar. Why we are keep here represented bar? Bar is the vector quantity. So displacement is the vector quantity. That's why here we are represent above the like arrow mark S bar. It is a vector quantity. Same as like as distance. SI is equal to meters, and CGS is equal to centimeters. CS is equal to centimeters. Displacement is the S bar, it is a vector quantity, SI is the meters, and CS is the centimeters. See, dear students, one more I will explain about displacement. Displacement, shortest distance between initial point to final point. So we are choosing like shortcuts way. So it is a displacement. Displacement, it is represented by S bar. It is a vector quantity, and the SI unit of displacement is the meters, and the CGS unit of displacement is the centimeters. I will explain to one example. So both distance and displacement, I will explain one example. So to find out the distance and displacement, example 1. So first of all, do you know you have 4 directions? East, west, north and south. I will say one example. A boy started origin moving towards east 4 meters. A boy is moving 4 meters towards east, and he take north. He take north side 3 meters. This is the initial point. This is the final point. The initial point of the boy. This is the final point of the boy. One boy is traveling towards 4 meters east, and he take U-turn like 4 meters. He is moving 3 meters north. So what is the distance and displacement? Here we should find out the distance and displacement, both we can find out here. This is the initial point, this is the final point. Let us, I will take this point is the A, this point is the B. So first of all, I should find out the distance. What is the definition of distance? Actual path of the total length between initial point to final point. So here to here distance 4 meters, here to here 3 meters. Total path will be covered. So 4 plus 3, 4 meter plus 3 meters is equal to 7 meters. 7 meters distance equal to 7 meters. But now this find out the displacement. Now find out the displacement is the S bar. Displacement is the S bar. Distance is the S, displacement is the S bar. This is shortcut. So what is the displacement definition? Shortest distance between initial point to final point. This is shortcut. We should find out this one. So we are applying the Pythagoras rule. What is the AB square? I like this. This point is a C. This point A, this point B, this point let us consider C. So here AB square is equal to AC square plus BC square. AC square plus and BC square. So we are applying here Pythagoras rule. AB square is equal to AC square plus BC square. AB square you don't know. So like this AB square. This one you should find out. AC square. What is the value of A? 4 meters. 4 whole square plus. What is the value of BC? BC is the length of 3 meters. 3 whole square. So 4 whole square means 16. 3 whole square means 9. AB square is equal to 25. So how to write 25? AB square is equal we can write 5 whole square. 5 into 5, 25. Square square will be cancelled. Finally, AB is equal to 5 meters. This value is equal to 5 meters. That is the displacement. So this is example 1. A boy is traveling towards 4 meters east and 3 meters towards north. You should find out the distance and displacement. Distance means actual path of total length between initial point to final point. D is A is the initial point, B is the final point. So distance means 4 plus 3, 7 meters. Displacement. What is the definition of displacement? Shortest distance between initial point to final point. We can choose the shortcut here to here. We should find out this one in the displacement. We are applying the Pythagoras rule. In mathematics, we are applying the Pythagoras rule. Pythagoras rule means AB square is equal to, this is the unknown. Unknown square is equal to, two sides. Two sides. So AC, and BC also, you don't know about AB. So you should find out the AB value. AB square is equal to AC square plus BC square. AB square is equal to AC square. The value of AC square, here the distance is 4 meters. 4 meters whole square plus the value of BC. B to here distance is 3 meters. 3 whole square. 4 square means 16 plus 3 square is equal to 9. Actually, AB square is equal to 25. 25, how to, we can write 25 AB square is equal to 5 whole square. 5 into 5, 25. Square square will be cancelled. AB is equal to 5 meters. So the boy is traveling, travel A to C. A to B is the 5 meters. Distance is equal to 7 meters and displacement is the 5 meters. This is the common examples of the distance and displacement. Next, some few points explain about distance and displacement. Some few points I will explain about distance and displacement. First point, in a rectilinear motion, when a body is moving in a straight line, distance is equal to displacement. Distance is equal to displacement. Both are equal. See, when a body is moving straight line, for example, this is the A, this point is the B. A to B distance is equal to 10 meters. Now we should find out here distance and displacement means distance is equal to displacement, both are equal. When a body is moving in a straight line, distance is equal to displacement. Distance is equal to 10 meters, again displacement also 10 meters. So don't get confusion, I will write like displacement means yes, the displacement is the S bar. S is the scalar quantity, that's why I will write like a single S, and S bar means this is the square vector quantity. I will represent like above bar. Distance is a 10 meters and displacement also 10 meters. Because of when a body is moving in a straight line, distance is equal to displacement, both are equal. That is the first point. And the second point is when a particle is moving in circular path, when a body or when a particle moving in a circular path, what is distance and what is displacement? When a body is moving in circular path, what is the distance and what is the displacement? Now first distance. Distance formula is equal to 2 pi r. So all of you keep in your mind this one. Distance is equal to when a body is moving in a circular path, formula is equal to circumference of circle 2 pi r. Here r is the radius of the circle. Already you know pi value. Pi is equal to 22 by 7 means 3.14. This value is constant value. Pi is equal to 22 by 7 and 3.14. This value is the constant. This is the pi value and 2 into pi into r. R is equal to radius of the circle. R is equal to radius of the circle. What about displacement? Displacement is 0. Displacement is 0. So all of you keep in your mind. Displacement is initial point and final point both are same. At that condition, displacement will be 0. Initial point and final point both are same. So when particle has started like this moving, and again come same place. Initial point and final point both are same, displacement is 0. This is about distance, this is the displacement. Next, third point. When a body is moving semicircle, a body is moving semicircle. So what is the distance, what is the displacement? Radius of the circle, this is also, this we call like diameter. So first we should find out the distance. Distance means you know already, in total circle means 2 pi r. 2 pi r. Half circle means by 2. 2 will be cancelled. S is equal to pi r. S is equal to pi r. And what about displacement? So this is total is the pi r, but here to here you can shortcut r plus r. To r plus r to r. These 3 points very important. All of you keep in your mind. Once again I will repeat. First one, when a body or particle moving in a straight line, distance is equal to displacement. And the second point, when a body is moving in circular path, distance is equal to formula 2 pi r and displacement is 0. Why here displacement is 0? Distance here, initial point and final point both are same. Initial point and final point both are same. On that condition, the displacement is 0. And third point, when a body is moving semicircle, what about distance and displacement? Distance is equal to already in the total circle 2 pi r formula, 2 pi r by 2. Half circle means 2. 2 will be cancelled. S is equal to pi r. And displacement means you can shortcut. Shortest distance initial point to final point. You can this is shortcut only. R plus r. R plus r is equal to r. These points about distance and displacement, remaining class will discuss about speed and types of speed. Thank you for watching. Thank you once again.